Welcome everyone, and from myself and Geethu to our presentation of COLib, which stands for, you'll find out in the first slide. And yes, I will give the floor to my colleague Geethu from CRESYM.
Hello, everyone. Welcome to the session. I'm Geethu Joseph. I work as an IT asset and project manager at CRESYM, and with my colleague, Lampros Papangelis, who is a scientific advisor. So here in the session, we talk about COLib. It's a collaborative open source library for power system components. And in the session, we will be covering what is COLib and whom it's for, and why CRESYM initiated COLib. And we give a comparative view with other initiatives in the community and how to contribute to COLib. And we had a COLib workshop yesterday, so we would like to share the outcome of COLib workshop. So what is COLib? So you can see it as a Wikipedia. So from CRESYM perspective, we refer it as a Wikipedia. So imagine something like that for power system where researchers or manufacturers can access well-documented standardized model, and that's what COLib is. So COLib is a shared platform where power system components, networks, and test systems are collected, documented, and standardized for both research and industry. So it is designed to be a central repository for power systems. So instead of searching through papers or building new test systems from scratch, you can find the components like generator, transformers, or controllers, which are ready to use within the repository. And COLib supports both steady state and dynamic studies like load flow analysis and dynamic simulations. So whether you want to simulate normal operations or dynamic events, then the models are ready within the repository that could be used. But that doesn't mean that COLib doesn't just store models. We encourage community contributions, quality checks, and also standardization. So think of it as an active library where people can add, modify, and evaluate the model. So it will be beneficial for others users to use it. Coming up of key contents of COLib. So we have steady state and dynamic, standardized, and specific power system components. So it's a combination of both simplified models that could be used for teaching, as well as detailed industrial scale simulations. Also, it have test systems, which are small, easy to understand. For example, control 2-area test systems, and bigger, realistic test systems, for example, Slovenian power system, which will be a potential contribution to COLib. And from both academic and industrial world, meaning we have models, it's a knowledge from both university and real-world operators. So it's not meant only about real models, but it is also educational, or it could be used for research perspective as well. And all the models and test cases that we have is well documented, and that means we have references to the papers and also links to the open source implementation that users can understand easily. They can trust it and can be reused safely. Now, whom it's beneficial for? So we have, this platform is actually defined for different users, for example, researchers, operators, software providers, and device manufacturers. So we can take it one by one. So academia and research institutes, we have the model, which is very high quality, verified models. That's what we aim to. And also, for the professors, they could be used as a training material for teaching, as well as the researchers can use it as a real-world example instead of looking into the theory and learn with the theory. It allows rapid prototyping. That means that researchers can build new algorithms based on the existing test systems instead of started from scratch. And the researchers, when they are done with a model, when they can contribute it to COLib, then they are getting a visibility to their work in the research community. And the system operators for distribution and transmission operators, they gain value through transparency. And also it's like various study scopes that could be from small-scale stability studies to large-scale grid analysis. And they can kickstart the research projects with the existing models and test systems instead of starting it from scratch. When we say real models and test systems, so these are the real models and test systems that could be used for any research projects within the research department. And for the software providers, the cost of the maintenance can be reduced by using the existing models. And also it is an advantage for the software providers where they will be getting an opportunity to know the emerging models and also the industrial needs. And it acts as a scientific watch to have a opportunity to know the potential models in the community. The device manufacturers, for the device manufacturers, when they share the models within this library, they gain visibility, and also they can contribute white box equivalent models, and that will help the researchers to test devices in simulation. And it also encourages the use of their products in research and promote their tool, and also it's an advantage to adopt in the community. So that's what we have identified as a potential users and the beneficial by using this library. Now, Lampros can provide a brief introduction to why CRESYM initiated COLib.
Thank you, Geethu. So I will try to answer why we need a library and why, as CRESYM, we started developing this library and what need do we think that we need to address. Before going to the more general stuff on the left, I would like to first speak about my experience from working with models when someone was starting to ask me, do a study or publish. And there were always, at least my side, I went through some different levels of how to do the study. When being a rookie, it was quite common that after you do the first step, that tells you, okay, which model you have to select and what type of software you need to use this model for, to do the study. It was quite common that you would take a model that has been done by someone else, maybe 5, 10 years ago, and probably undocumented or unvalidated. You would plug this into your model, maybe do a little bit of tuning, and then try to provide and get some meaningful outcomes and conclusions out of this. At first, you say, okay, I found the model, I saved a lot of job for me, but then you realize that problems exist. This problem of validation and non-documentation will eventually come back with a vengeance, and we'll probably have to rush a bit at the end to provide something meaningful. And of course, the correct idea would be that after you select the model, you will do some appropriate research or the literature. You will do the model, you will build the model on your own, a new model, the appropriate model on the software that you want, you will validate it, you will tuning, and eventually you will come back with some more meaningful results. But this takes time. And it takes time to build the model, to debug it, to do a lot of things, to validate it, and so on. And eventually, hopefully, you will save some time at the end for documentation. And it's not uncommon that half 50% of the budget that you have is spent on this topic over there. So COLib, from my experience, it would be something that could facilitate these first steps. You find a validated model, well documented, with some good data sets, and we do a little bit of tuning, and eventually you come back with the results. This is from my experience, but if you are a power system engineer and you didn't fall from the sky yesterday, you probably realize that you have heard several times that we get a lot of new equipment, inverter-based resources. Each inverter comes from a different vendor, small vendors, big vendors. Models are not transparent. There is a lot of IP protection in there. And sometimes you have some black box models that behave quite differently. They don't behave as what we used to do when we had synchronous machines in the past, where we knew their physics. There were decades of investigation of their dynamics, and we had very detailed and very validated physics of machines that we knew how they would behave, and we knew what controls and standards were there for the controls to use on. So we saw that we would like to have more up-to-date models for these new components. We wanted to have more data sets, an up-to-date library of these components that follows the technology faster, and standards take a lot of time to be updated, but a library can be a bit more flexible, especially, and accommodate also the latest results of the research. And not only that, we have the models, but we need to plug them in somehow to something to test what these models are meant for. And especially with inverter-based resources, new task force reports came out some years ago that said, look, we have to face new instability problems. We have to study those. We have to build test systems for those. So all this development and energy transition that happens in the power system, we believe that deserves and necessitate, not just deserves, to have a model, a library where you can add more models and keep them up to date and validate them. But of course, we're not the first to do this. There have been some projects in the past. Someone would ask, why do we need one more library? We have IEC standards, we have WEC standards. We can take those standards over there. There have been several European projects. I can think of some that finished in 2016 that developed their own libraries in some software. Each vendor, software vendor, Power Factory, PSCAD, OpalRT, they have their own libraries that they have developed and so on throughout the time. And yeah. So there is already some material on the web on this. And as CRESYM with COLib, we don't just want to have a library where models go to die. We just want to keep it alive. We want to keep it up to date all the time. And we want to make it easy for people to use and to expand. So our idea is that we will combine several various dimensions of these previous initiatives, and we will not focus only on building a repository. So we want to make it easy to use and expand. If we have COLib in the middle, so our website focuses on 5 different pillars. We want to have a clear model description that comes from the standards or from the libraries with consistent also description of among different models. We want to have open source. We focus to have mainly an open source, but also transparent implementation. In several libraries, there are always some hidden tricks that the developers have done that most of the times are not documented in order to make them behave as what they would like to behave. We want to make it easy to use and contribute, and for that, Geethu will speak in a while about how people can contribute and how this can become a community work, a collaborative and volunteer work, and not just 2 people adding models and updating them all the time. And we also go through to its model, we review it, its entry, we review it, and we ask for validation in order to ensure a good quality of the model. I left for the end a future development that we are planning is that models are nice, but we also want to make it, but we don't want to restrict them to some implementations. We want to add to have a list of tools around COLib that will facilitate the translation of models, but also help people download the models that they want in a civil test case and use them to, at first, understand them, and then the software of their choice. I think that's what I wanted to go, and I think that it's COLib is back to Geethu.
Thank you. So instead of just going through this presentation, probably I can go live through the website itself. So this is our official website, colib.net. And as you can see, you can have a quick access to the models and the test systems. So we have, currently we have models, which is on the left-hand side. As you can see, we have categorized into different sections. And we have this contribution from academia, industry, as well as from the software providers. So we are encouraging all the partners over here, all the audience over here to have a look into this website and see the potential of contribution. So in the models and test cases, before talking about the contribution, for all the models, we have maintained consistency throughout the layout. That means, as Lampros mentioned, for each model, the context, the descriptions, the parameters, the equations, and also the open source implementations, if any, and also the references to the papers. So everything related to that model is linked. At the same time, for the test cases, that's the case with test cases as well. So we have maintained consistency throughout in the library. To maintain this consistency, we encourage all the contributors to look into the model template as well as template for the test case, that they can download it and they can make the changes and upload it. So if you are not familiar with the GitHub, this website is based on GitHub pages, and all the documentations are based on Geethu Markdown files. So if you are not familiar with GitHub and would like to contribute, you can quickly download the model template. And we have also provided the steps how to contribute and the submission process, where it will take you to create an issue. So create an issue, and within the issue, you will get notified what you will get notified what type of models or test cases you would like to add. So in Geethu, Geethu got access. Geethu got a limitation that we have seen, that we cannot add directly the QMT file to GitHub issue. But at the same time, if you can add it as a zip file, that is possible. So recently, last month, we migrated from Jekyll to Geethu, and that's because we received few feedbacks from the contributors who have already provided their models and test cases to this. So to make the contribution much more easier and comfortable, that's why we have moved to this platform. And if you are familiar with GitHub, then you can create an issue. Let's say you are going to contribute more than 5 models, then you can create an issue for each models or just one model, and we from CRESYM, one staff will be connecting with you to give a proper guidance about the process that we follow to upload the models, and also the review and the process that we maintain throughout in the process of publishing the page. And so that's about how to contribute. And also we have provided the basics of Geethu as well as an interactive tutorial within our website to give a quick walkthrough to, if you are new to this, how you can plug and play around. And we have also provided the naming conventions and the standards that we maintain in this library. So that's about how to contribute. So as I said, as I mentioned before, yesterday we had a COLib workshop with 15 participants, and it was an active participation. And we have received quite a good feedback and also inputs from the participants that we would like to share here.
Okay, hi. Okay. So there were a lot of questions. We got some feedback, quite a lot of feedback, so we'd be happy to receive feedback also today, of course. And about why, if we are alone in thinking that this is, for example, beneficial from organizations. And we got several answers that indeed we can, such an initiative, such a library, would help people and get similar models, so compatible and consistent results between different researchers. At the same time, we could get a lot of legacy management, especially, and it's very useful after PhD or research project finishes that no one cares about them anymore, the models. They are left some DLL somewhere, and well, 5 years later, when someone decides to take them and use them, it's not so possible anymore. So it's good that this documentation ensures that we can keep the legacy of the project, which is also one of the main objectives of CRESYM. There were some inputs about also what else we could, where we should focus of the contents of COLib. And we got that it's very useful to have EMT, but also RMS and real-time models, and quite some inputs on having on using datasets, having datasets to these models in COLib, so that people can take them and use real datasets already tuned for some particular, of course, use cases. And yes, I think this is yours. So about.
Which sources should we link or update? So this is what we have received, the potential contributions from let's say, Oleander, Power Grid Model, then VeraGrid from eRoots, and also contribution from Open Mobility Association, Interopera. So this shows that there is a good interest for the contribution to this library. And we are looking forward to this contribution in the next coming year. The next steps, what we are looking forward is to populate the library with models. Now we need to discuss in depth how we are going to do it. Now, after the discussion yesterday, we really feel like we need to have more discussions like this to strengthen the links with the software providers as well as the vendors as well. And developing the benchmark test systems and prioritize the tools development for the COLib. So that's the next step that we have planned for. So thank you so much. If you have any questions, yeah, please let us know.
Thank you. Yes, we have MatPower in mind, of course. I would say that it's more, I'm not sure about industry, but it's certainly very much accepted by research. We have them in mind, of course, and we would like to have also models from there inside, because they are also open source inside their documentation. And we want to expand this documentation by, by all these different things in parallel that we have And we would like to have COLib, so clear documentation, clear description, and not only to support a senior researcher, but also to help a junior researcher to come and take this model. And but we don't want to be specific to any particular software, so MatPower. We want to expand this. Of course, we will provide. We can certainly provide. Now we have a lot of implementations in Modelica, because we are collaborating quite a lot with RTE, so with Modelica we have some input in there. And yes, the idea is to populate it as much as possible, yes. And base ourselves also on Modelica, but also the results of iTesla in the past, and so on. So thank you all very much for your attention.